about 1-4, measuring angles from the textbook, just to review and go over this. Which angles below, if any, are the same size as the one at the right? Describe 2 ways you can verify. We're looking at this angle over here. We're supposed to compare these. Which ones look like they would be the same? Now there's several of them that could possibly be the same. If I was going to put them in a category, I'd say angle A, angle C, angle D, and maybe angle F. Angle E is quite possibly, it looks a little bigger, but it may be the same. Now it said name 2 ways you can verify it. To verify it, the first thing, just looking at them real quick, I know that it's less than a right angle. Of course, angle G appears to be right. A right angle is a 90-degree angle, and of course we're talking about types of angles here, but I know that you're familiar with right angles at this point, so you should be able to tell that this one is a little larger opening than that one. F looks like it works. Of course, E, D, C, and A are all less than that. B looks real close to being a right angle. So to verify it just by eyeballing it, we're not really sure. And what they're trying to do here, they're throwing you off a little bit. Look how big the little arrows here are on the end of these rays, and the arrows are different on these rays. But you can't allow that to confuse you. What we're looking for is the distance between here, the 2 rays, to see if it compares. Now this one may be bigger than this, but again, unless we measure it, find the measure, it would be hard to determine that. But still, just looking at them, comparing angles, when we look at angles, the length of these sides really do not matter because they're made up, they're raised so they have arrows on the end, so that doesn't matter. What matters is the distance between those 2 rays at any point. So in this lesson, you're going to be learning how to describe and measure angles like the ones in the solvent. Okay, so we can measure them. Down here at the bottom of the page, we have some vocabulary in this key concept box. It says an angle is formed by 2 rays with the same endpoint. 2 rays with the same endpoint. That's what forms an angle. So if they ask you for the sides, they're the rays. The rays are the sides of the angle. The endpoint is called the vertex of the angle. So looking at the angle they have in this diagram, this angle can be named several ways. Okay, one of several ways. First, we can call it angle A. We can call it angle A because there's only one angle at that vertex, so we could call it angle A. Or we can name it with 3 points. We could call it angle BAC or angle CAB. And the way we do that, we put an angle symbol in front. That's the symbol we use. So we could call it angle A, naming it for its vertex. That's if there's no confusion that angle A would be more than one angle. In this case, there's only one angle there, so that's all it could be. But the best way to do it, of course, is with 3 points if there's any confusion, like angle BAC or angle CAB, but the vertex A must go in the middle of the name. And then on this one, of course, we could just call it angle 1. Now the 1 doesn't indicate any kind of measure or anything like that. It's just to identify it. So if we had something, let me draw an angle real quick just to show you. If we draw an angle that looks like this, or we have maybe a couple of angles. Say this is one vertex, but I have several rays here. If I want to call this, say that's B, and I'm going to come up here and call this C, this D, and I'm going to call this E. So now I cannot identify any angle by just saying angle B, right? Because it could be one of 3 angles. There's 3 angles here. Now a lot of people look at it and say, well, I only see 2 angles, but there's 3. We've got this angle between those 2. We have the angle between those 2 rays, and then we have the whole angle. So that's 3 different angles. So we can't call this angle B. There's 3 different angles there. We wouldn't know which one we were talking about. So in a picture like this, we're going to have to use 3 points. See, the angle up here, we could say angle CBE. CBE would be this angle. The other small angle would be angle EBD, always putting B in the middle. If you don't put the vertex in the middle, you're not naming the angle. And of course, then we have the larger angle, the whole angle, which could be angle CBD. So those are the 3 angles that are pictured there. All right. Now another way, and using those numbers like they did in the book, the 1, this is a convenient time that we could put angle, put a 1 inside. That's a label now. It's not a number. It doesn't mean any has real numerical value. It's just a label. Label angle 1, and then we could label this one angle 2. Okay? We wouldn't say that the whole angle, angle CBD, is angle 3. You don't do anything. Those labels just make it quick and easy when you're looking at a picture with a bunch of angles. When you say angle 1, it's quick and easy to identify. You don't have to look and trace around the angle. When I say angle CBE, which is the same angle, you have to look CBE to determine which one you're talking about, which two rays the angle is formed by. So angle 1 and 2 are just convenient ways to make it easier to name angles real quick. And just like with segments and lines, sometimes we can name these angles different. See, I call this angle CBE. I could also call that angle EBC. It's the exact same angle. I'm just going around it, EBD, or EBC instead of CBE. I'm going around it a different way. Just like this angle, EBD, we could name it angle DBE, just flip it around. Notice B is still in the middle though. We always have to do it in the middle. And then the last one we could go, of course, reverse it and call it angle DBC. Okay, so these are the same angles. I just named them going around in either of the two ways. But we couldn't name anything angle B here. Of course, this angle here was also angle 1. That's another way of naming it. And this angle was angle 2. So we could name these two angles in 3 different ways. And those two, of course, in 2 ways. All right? So that's what that label is for. That's what angle the 1 is for, just to help us have a quick way of identifying it. Now, something you're going to have to pay attention to, we said an angle is a figure formed, or an angle is formed by 2 rays with the same endpoint. If I ask you for the sides of the angles, they're rays, ray AB and ray AC. Those are the sides, ray AB, ray AC. And the vertex is the corner point or point A in that picture. Okay? Just like in the picture that I previously drew, if I was looking at angle 1, the vertex of angle 1 is B. The sides of angle 1 are ray BC and ray BE. Those are the sides of angle 1. Okay. All right. Down here at the bottom, they mentioned something that will be important later on. So when you name angles using 3 points, the vertex must go in the middle. I already mentioned that. And then there's an interior of an angle. The interior of an angle is the region containing all the points that are between the 2 sides, and the exterior are all the points or the region of points contained on the outside, not on the interior. Of course, it would be exterior. And remember, these are rays, they continue, so that interior is a lot larger than what they show here. Of course, the exterior is everything outside of that region. All right, so a little more about angles. Over here on the next page, they have examples, and they're talking about naming an angle. And again, this is kind of like the picture I drew a moment ago. What are 2 other ways to name angle 1? Angle 1, well, we can name it going around it. Angle JMK or angle KMJ. Those are the 2 other ways of renaming or naming angle 1. Again, we can't say there's an angle M. It'd be incorrect at saying that here. It would be, would it be correct to name any angle M? No, there's too many angles there. We can't identify which one they're talking about. Even if we're talking about the larger whole angle, we need to do it with 3 points, either J, M, L, or L, M, J. But most of these angles, we can name them with several different ways, either with a number, 3 points, and then 1 point if there's only one angle. One way to measure the size of an angle is in degrees. I say one way. Later on, when you go to a trig class or something like that, there's other ways that are used in mathematics, but the one that we're going to use is the one that you're probably already familiar with. We measure them in degrees. All right, so one way to measure the size of an angle in degrees is to indicate the measure of the angle, write a lowercase m. That's how we say, hey, I'm looking for the measure of angle A. The measure of angle A. Put a little measure. That angle over there is 62 degrees. Okay, so that's where we get that. Now we have something called a protractor postulate. In the last section, we had a ruler postulate. We measure segments with rulers. We measure angles with postulates. We have what's called the the protractor postulate. Sorry. All right, so for the protractor postulate, it's similar to the ruler postulate, but a ruler is just for linear measures, and it's like a number line. This is a little different from a number line. Of course, we have a protractor. There's 2 sets of numbers on my protractor. On the outside, you can see it goes from 0 to 180 in that direction. Then on the inside, we go from 0 to 180 in the other direction. So we treat it a lot like a number line because it's split up in degrees, what a degree would be, or what 10 degrees or 20 degrees, no matter which direction you're going in. So to measure an angle, it's kind of like the protractor project. It says consider a ray OB, okay, we have this ray OB, and a point A on one side of it. So or either on this side or this side, but in this case, of course, it's on this side. On one side of it, every ray of the form OA, just going from the end point of this ray to wherever that point is, wherever A would be on this side of it, can be paired with one to one, with real numbers from 0 to 180. So where A is, when we draw that ray from 0 to A, it looks like it's paired with the number between 120 and 130, which would be 125, or it's paired with a number between 50 and 60. Now you have to determine what kind of angle you're looking at. Notice the other side of the angle is at 0, and this angle opens very wide. And really wide angles like that are going to be obtuse, and for obtuse angles, they're more than a right angle, more than 90 degrees, so you're going to use the bigger pair of numbers to measure that angle, the angle BOA or AOB. So it's going to be the 125 degrees according to that picture. So what you do is you look at that number that pairs with the ray, and actually you subtract the number that pairs with this side from the number that pairs with this side. And in this case, that number was a 0, so there's nothing to subtract. See down here at the bottom, it's going to tell us the protractor postulate allows you to find the measure of an angle. Consider the diagram below. The measure of angle COD is the absolute value, just like with ruler postulate. It was the absolute value of the difference of the coordinates. This is going to be the absolute value of the difference of the coordinates of the two sides of the angle. Now, most of the time when we're measuring an angle, we like to do this. We like to put the little view finder thing on the vertex, on the corner point. We like to put one ray at 0. That way we can just read that number because there's nothing to subtract from that number. But we could actually find the measure of the angle in this way too. We got an angle COD, right? And instead of having to worry about whether it's obtuse or acute, we just use one of these sets of numbers. Like for instance, if you look at this ray here, we define the number that lines up with it. It looks like it's probably about a 32, maybe about 32. And this one looks like it falls in at 135. Okay, so 135 minus 132. Or you could do it the other way, 32 minus 135, because it wouldn't matter. We're looking for the absolute value. So it's going to be positive. So it wouldn't matter if you put the big number minus the small number, or the small number by the large number minus the larger number. As long as you do absolute value, you still get the measure, or it's going to be a positive measure. Okay? So by putting this at the viewfinder, you just read the numbers off the two angles, get the difference between them, just like protractor postulate. We get the difference between the coordinates. We get the difference between the coordinates of the sides of the angle. Now, again, I used 32, the smaller one, so I had to use this number over here. Since it's 32 going over this way, it's getting larger, you have to use the larger number. I could have done the same thing if I'd have used the large number here and went over here and got the smaller number. You should have been able to get the same degree measure, okay, by subtracting and getting absolute value. So now over here, this is what I was talking about a moment ago. You look at an angle and you can look at the shape of the angle, kind of determine what its measure is going to be. Now on the vocabulary, I expect, when I ask you to do vocabulary, I expect sentences. I don't expect you to just write down and draw a picture. And some of you just copied this out of the book on your vocabulary. That's not a definition. A definition of an acute angle is an angle whose measure is between 0 and 90 degrees. Okay? That's a definition. A definition is a full sentence. Okay? You should have a complete sentence when you write a definition. A right angle is an angle whose measure is equal to 90 degrees. An obtuse angle is an angle whose measure is greater than 90 but less than 180. You've got to include both. And then there's a straight angle, an angle whose measure is equal to 180 degrees. Okay? So when you write your definitions and turn them in, I don't accept them unless they're complete sentences. So before you turn them in, make sure that your answers are complete sentences. Don't just copy stuff. We'll talk a lot more about definitions in Chapter 2, but in Chapter 1, you need to go ahead and get in the habit of doing that. Now, they mention, and something's wrong with this picture, they mention this little box here. I guess not, because there's no angle there. But this little box inside of an angle is the way that we signify that that's a right angle or a 90-degree angle. Okay, and they mention that. Then down here they say measuring and classifying angles. To find the measure of an angle, they find a measure of a couple of angles. First of all, they angle LKN. LKN. Well, the good thing about LKN, all we have to do is get the coordinate on the ray KL, which is 145, subtract 0, because the ray KN corresponds to 0, so it's a 45-degree angle and it's obtuse. And again, by looking at the angle, we know we're going to use the bigger set of numbers rather than that smaller one. We know that's not a 35-degree angle because it's larger than that. It's obtuse. It's more than a right angle, a 90-degree angle. To find angle JKL, JK, and did I read that right? Yeah, JKL. Oh, I'm looking JKL. This one. I'm sorry, looking at it wrong. JKL. See, this time we're going to have to read both numbers and get the difference. So they have 90 degrees for that ray, 145 degrees for that ray. Getting their difference, see, gives me a negative because I subtracted the larger from the negative, or from the smaller. I mean, you can flip it around, but the whole point is the angle is always going to have to be, when we're finished, a positive number, so 55 degrees, and that's an acute angle. And then, of course, JKN, that was a right angle or a 90-degree angle. So that's measuring angles. That should be pretty easy to do. Now, just like with segments, we have congruent. Congruence means same shape, same size. Okay, so with angles, unlike segments, segments are all basically the same shape. The size of the angle determines its shape. So if same shape, same size, congruent angles mean they're going to look a lot alike because their measures are the same. So angles with the same measure are congruent angles. This means that the measure of angle A equals a measure of angle B if their measures are the same. If they're both 30 or they're both 36, then they're congruent. Angle A is congruent to angle B. And you need to make sure that you know how to read that when you see those statements. You can also say that if angle A is congruent to angle B, then their measures are going to be equal. So it works both ways, vice versa. And again, we'll talk about that a little bit in Chapter 2. Most of the things we study in geometry, if one thing's true, if one thing makes another thing true, then it's vice versa. You can flip it around. So if the measures being equal make them congruent, then them being congruent means their measures are equal. That's what I'm talking about. All right, so on the next page, they just illustrate something about congruent angles with synchronized swimmers. One thing they want to do is form congruent angles and be symmetrical and everything look, the same. If they don't look the same, then they're not synchronized. Okay. And then we have angle addition postulate. We had segment addition postulate. Now we have an angle addition postulate that the sum of the parts is equal to the whole. That whatever the measure of this angle is, and the measure of this angle will be equal to the measure of the whole angle. See, they tell us here, if B is on the interior of angle AOC, then the measure of angle AOB plus the measure of BOC will equal the measure of AOC. Okay? So if this one were, say, 20 degrees, and this one were 40 degrees, well, no, it's more than that because that's a big angle. Let's see, let's say that one looks like it's about 90 degrees. If that's 90 and that's 20, then the whole angle would be 110. That's how simple that is. That's the idea. Segment addition, now angle addition, it works kind of the same way. And so we're going to have to solve equations, just like what we did with segments, but now we're dealing with angle measures. In this picture at the top, they tell us that the measure of angle RQT, this whole angle here, RQT is equal to 155. What are the measures of those two angles? Well, in the picture, they tell us RQS is just 4x minus 20. TQS is 3x plus 14. Since the whole angle is 155, if I add that one to that one, they equal 155. So that's what they've done over here. They said the measure of angle RQS plus the measure of angle TQS is equal to the measure of angle RQT. So that measure, substituting those algebraic expressions for the measures of the angles, we get an equation that we can solve. 3 and 4x is 7x, negative 20 and 14 is negative 6. Add 6, 7x is equal to 161, so x is 23. Now the question didn't ask for x, but we had to find x. Now that we found x, we can find the measure of these angles. The measure of angle S was 4x minus 20. So 4 times 23x minus 20, 92 minus 20 is 72. And the other one, for TQS, plug in for the x, 3 times 23 plus 14, or 69 plus 14 is 83. And notice when we're finished, 72 plus 83 added together is equal to 155. So that's real simple process. Now this next one, they don't tell us the measure of the whole angle. They say it's a straight angle. So since it's a straight angle, that's 180. So we can say that this angle measure, 11x minus 12 plus 2x plus 14, 2x plus 10, is equal to 180. Then you just collect like terms, solve the equation, find out what x is, plug it back in for these measures, and find each of those measures. Okay. It's real simple. I don't think you'll have too much trouble with this. One other thing that I don't know that I mentioned over here on the other page, we have angles that are congruent. Angles that are congruent, just like with segments congruent, we put little tally marks. We put little arcs in the ones that are congruent, like that. Angle A is congruent to angle B, we put those little arcs in there. So if there's more than one congruent, we put a couple of arcs. Like over here on this page, you can tell by looking at this picture that this angle is congruent to that angle because they both have 2 arcs. This angle, the one down here at A, and this one are congruent because they have 1 arc. And then these have 3, so they're congruent. So that's how they mark congruence of angles in a diagram. Okay, so good luck with the worksheet.